This video will look at how to do hypothesis tests for two averages using the TI-83, the 84, the 89, and GeoGebra. In this problem, I'm comparing the average battery life for Energix and Durabell's batteries. I sampled 101 of each type. I have the information there to decide. As always, when I'm comparing more than one group, it's a really good idea from the start to label which group is which group. So my group 1 is Energix. My group 2 is this Durabell's battery. So in my TI-89, I'm going to go to the same spot where I always go for test, which is apps, and then stat list editor. And then test is up top at F6. So I'm hitting blue F6. I'm comparing two samples. I'm using t-scores. So the name of this thing is a two-sample t-test. It asks me if I want to do stats. That's if I have all the summary statistics. I do. Or I can use data if I have all of the raw data for the 101 individual values for each of those samples. I don't. First, average. So I'm typing in information for my first group. I'm typing in the information for the second group. And then I'm testing for a difference on this one. So if I think the first average is less, I would choose this middle option. If I think the first average is more, I choose the bottom option. I'm testing for a difference. I have the option for pooling. Pooling assumes that your two standard deviations are relatively close to one another, and it kind of averages those things out to come up with one clean standard deviation to use for the whole problem. Effectively, it's not going to make that big of a difference if you pool or do not pool. So I typically do not pool when I'm doing these two-sample t-test. I will go to calculate. This gives me my p-value there, 0.118. Interesting thing, your degree of freedom when you're comparing two averages, you'll end up with decimals. So my degree of freedom here was 190.806. It's kind of weird to end up with the degree of freedom that's a decimal, because if you're used to using a t-table, there's usually just whole numbers on the side and your percentages for the column. So this is a little different. But when I did this in my calculator, I got a p-value of 11.8% or so. It's a fairly large p-value. I would fail to reject the null hypothesis. I don't have a difference in the two averages. Let's see what this looks like now in the 84. The 83 is going to work exactly the same way. Functionally, the TI-83 and 84 is the same calculator. The 84 just looks a little bit nicer. I'm going into stat. I'm choosing the option for test. And I am comparing two samples using a t-test, so two-sample t-test. I have the option of either doing summary statistics or raw data. I have summary statistics here. My values were 10, 2, and 101. My values were 9.5, 2.5, and 101. And I'm testing for a difference. Just to show you what happens if you pool, and I typically choose the option for not pooling here. So I end up with a p-value of 0.1181. Going back in here to sample t-test, 0.1181. Well, let's see what happens if I don't pool. 0.1181, so I'm getting effectively the same value. So if you pool or don't pool, it really is not going to affect your results that much. I find that it's sometimes unreasonable to claim that your two sample standard deviations look the same. So by default, I think no is a really good answer. Let me show you how to do this now in GeoGebra. GeoGebra stuff is always inside of probability, so when I open it up, I choose probability. I go up to the top where it says statistics. And inside of statistics, I'm choosing the option that says t-test, and I'm looking at a difference of means. So I am choosing t-test, difference of means. Null hypothesis is going to be 0. That represents there being no difference. If I think the first group is larger, I choose this middle option. If I think the first group is smaller, I choose this first option. I'm testing for a difference. I'm doing a two-tailed test, so I'm choosing not equals. I type in my data. Still the same numbers, so I have 10 to 101. I have 9.5, 2.5, 101. This gives me my t-score of 1.57 or so, and it gives a p-value of 0.118. I'm getting the same p-value no matter what technology I'm using, so use whatever technology you have available or whichever technology you're the most comfortable with. I will make another video for doing confidence intervals for two averages. That's a good thing to do as a follow-up after you do a hypothesis test. Those two things are usually paired together.